right, so here we've got our cool down, our exit ticket from our exponentials day one. And what we're looking at is comparing two different types of changing, two different types of patterns that each change consistently. And so we have two different islands, Meow Island and Per Island. And if you notice in each of those, the X values are just going up by one. It's always a good idea to double check that your table isn't written out of order or that the X values don't skip around or anything like that. So just make sure you're looking at both of the numbers that are changing in the table to make sure nothing funky is going on there. When I look at the number of cats here, I can see that we went from 2 to 6, from 6 to 18, from 18 to 54, and from 54 to 162. And that is growing very rapidly. And what I notice is it's not adding the same amount each time. It's not adding, say, 4 each time. If I do 2 plus 4, I get 6, but 6 plus 4 is not 18. 18 plus 4 is definitely not 54. What's going on instead is if you notice, 6 divided by 2 is equal to 3. So is 18 divided by 6. So is 54 divided by 18. And you can use a calculator to check this if you want. But what I'm noticing is that on Meow Island, it is multiplying by 3 each year. So for some reason, the number of cats on Meow Island are multiplying by 3 each year. For the Per Island, we could try the times 3 pattern. 2 times 3 is 6, but then 6 times 3 is not 10, and 10 times 3 is not 14. And so we can see that this is not a consistent multiplying pattern, but it is a consistent adding pattern. If you notice, doing 6 minus 2 is adding 4. Doing 10 minus 6 is also adding 4. And doing 14 minus 10 is also adding 4. So the Per Island is adding 4 each year. That is a perfectly okay answer for starting out the unit. You're just verbally using your words to describe the pattern that you're seeing. What I'm going to build up to is this sort of answer where we write a function for each of them, where the letter x stands for the number of years, the m of x is the number of cats on Meow Island, and the p of x is just the number of cats on Per Island. Okay. And what we can do here is use our knowledge of the patterns to try to write it as an actual equation, like a formula for how many cats there are. And what I notice is that both of the islands start with 2. But then different things happen after that. The Meow Island multiplies by 3. That would get me to 6, and then it multiplies by 3 again to get me to 18, and it multiplies by 3 again, and it multiplies by 3 again. In fact, every year that goes by, it multiplies by another copy of 3. And we can use an exponent to show that idea that you are multiplying by copies of 3 repeatedly. And the letter X, when it's written up top and small like that, tells you that's the number of 3s that you are multiplying. Very similarly, Per Island starts at 2 and it adds 4 each year. Notice that the X here is not written up top as an exponent, it's written in the main line, and that just means 4 times the number of years. Over a 2-year period, you're going to add 4 times 2, you're going to add 8 cats. And you can double check that that works if you look in your table. 2 cats plus 8 cats over a 2-year period gets you to 10. Compare that to Meow Island. Over a 2-year period, you're going to multiply by 3 twice. That's 3 squared. 3 squared is 9. Look what happens as I go from 2 to 18. I'm multiplying by 9. So that's what we're working towards. If you're right here right now, where you're just describing it with words, you're exactly where you need to be. All right, let's look at the other side here. Here we have a situation where we have a genie who's giving you a choice. You can either choose money that's in purse A, represented by this line, or you can have money that's in purse B. And the question here is not which one is a better deal always, because it depends. It depends on how many days go by. And so you need to, when you're trying to give advice about which purse you should pick, your answer needs to depend on the days. Because it is true that the purse that I drew with a red curve will eventually be better than the purple line, but it's not always true. And so the key idea here is that you're looking at the point of intersection right here. These two graphs cross over at 10, comma, kind of hard to see, maybe 2200-ish, maybe 2300. This is just sort of an estimate. And what that means is that if less than 10, then you want to choose the purple graph, which is purse A, because it has more money. But if, and this time I'm going to use the symbol, if greater than 10, choose B. And if it equals 10, they're equal, so it doesn't matter. Okay, so that was sort of the takeaways from our first lesson, exponentials. Please ask questions if there's anything I can do to help.